Okay, let's continue our review of Unit 4 by looking at 5C and 5E. I grouped these together because these both deal with graphing. Okay, so 5C talked about statistical tables and graphs and types of graph. We have two types of data, quantitative, which is measured or counted, and qualitative, which describes quantities. Okay, now, I'm sorry, qualities. I beg your pardon. I do that all the time. Okay, for quantitative data, we had two different types of graphs. We had a histogram and we had a line graph. On these, both axes are numbers. On this one, it's going to be the width of the bins, and the bins have to have an even width. They have to be the same size. And then the vertical axis is the frequency. How many are in what particular bin, and that tells you how tall the graph is. And in a histogram, the bars touch. Now notice here, there's nothing in here, but there is a bin there. These are all the same width, or supposed to be, and that means there's nothing in here. Okay, and there's nothing over here as well. Okay. For a line graph, all we do is take the value of the bin and we connect those dots with lines. The axes are the same. They are both numbers. This is a number, and you would have the same bin widths here, and this is the frequency. Now, the big difference between this and qualitative is one of your axes is not a number, it's a category. Okay. So qualitative describes qualities. Now you've got a bar chart here, but notice the difference here are the bars don't touch. The height is still the frequency, but each of these is a category. The one we did in class was fast food restaurants, or you could do, I don't know, favorite TV networks. Whatever, but you would list all the categories here, and the frequency, how many liked each of those as their favorite, would be there. Now, traditionally in a bar chart, since there's, numerically, you have to go from small to large. Here, you do your tallest category and then go down from there. You don't have to, but that is traditionally what is done. Okay. So this is when you have categories and a frequency. Here in a pie chart, the difference here is you have categories and percents, which add up to 100. So in the pie chart, everything's going to be within this circle, and everything's going to be filled in. Every section is going to have values in it, but they're going to be marked as a percent. Okay, and we did that when we looked at the one with the fast food and converted. Well, we started out with percents and did a pie chart, and then we took the percents when we knew the total number of people, converted them into values, and did the frequency. Okay, now there is some vocabulary for the histogram. So here's what you're going to need to know. You're going to need to know the difference between quantitative and qualitative data and which graphs work for each type. Here, either one of these, it gives you exactly the same value. Here, again, there is one that works better when you have percents and one that works better if you have an actual count, if you have a frequency instead of a percent. And of course, if you know the total, you can convert back and forth between those. There is some vocabulary for a histogram. You need to know what a bin is. It's a range of values. They're all going to be the same width. You're either going to have bins of 5 or bins of 10 or bins of 2 or bins of 100, depending upon what your data is. And the right-hand rule is that the endpoints are included in the bar to the right. Okay, so if you had a bin of 95 to 100, and then 100 to 105, a value of 100 would go in this bin. This would actually be 95 to 99.99999. Okay. The frequency is the number of data points in a bin, and then the relative frequency is the frequency as a percent, which is the frequency divided by the total. Okay, so that was it about quantitative and qualitative data. Then we went to scatter plots. And scatter plots are different because they examine two variables in the relationship. Okay. Now we had three different kinds of graphs on here. We had a correlation or a trend. And on this, you would want to draw a line. A positive correlation, and the trend line would look at the data, and it would kind of go following the trend of it with about the same number above and below. It may not go through any data points at all. Here is a negative correlation, and you read a graph from left to right. So a positive would be up from left to right, negative would be down from left to right, and then none, there's really nothing you can do with that. But you're comparing one variable to a second variable. Then the strength is going to be strong or weak. And the strength is how close are the data values to the line. So what I do is I just kind of, draw a little picture around. I just corral the variables and see how close that is to the trend line. This is kind of a judgment call. Mathematically, there are ways to find, it's called a correlation coefficient. And here, since there is no correlation, that's going to be a big old fat one. So the longer and skinnier it is, the closer it is to strong. The fatter it is, the closer it is to weak. So you're going to need to know correlation definitions, what they mean, strength definitions, know what they mean, and you're going to need to know about correlation versus causation. There are three different categories for that. A coincidence, okay, where there's no relationship between the variables. It may look like there is a correlation, but it's a coincidence. My favorite one is the number of pirates and the temperature, global temperature. Okay. Common underlying cause is when there is something else that is causing both of them. It might be, so like, I'm trying to think of one we did in class. But there are any number of them that would impact both. For example, one of the ones that I've seen in the news is that there is a positive correlation between the number of ice cream cones sold and the number of murders in New York City. Well, murder doesn't cause eating ice cream doesn't cause murder, but both of them are a result of the temperature. The higher the temperature, the higher the murder rate, and the higher the ice cream cone sales. So there is a common underlying cause. And then a direct cause, which is where one variable directly causes the other. If you took the example of New York City, if you compared temperature to murder rates, there would be a direct cause. The higher the temperature, the higher the murder rate. Okay. Or the higher the temperature, the higher the ice cream cone sales. Okay, so that's what you need to know in order to be successful on this. Okay, and let's see if there's anything else. No, that was kind of short. Okay, the end.